Hello guys, welcome back to Bimbel Bilcen. In this video, we are going to learn about general motion using calculus. We already learned in the previous video that if we have a motion with constant acceleration, we can apply SUFAT to deal with them. But how about non-constant acceleration? So we need to think another way because we cannot use SUFAT anymore and we can use calculus instead. Yeah. So calculus can be used to solve general motion, whether it's non-constant or constant acceleration, even though we prefer SUFAT for constant acceleration because it's easier. Now, how do we use calculus to solve non-constant acceleration or motion in general? So we can write displacement, velocity, and acceleration that we have as a function in time and apply differentiation or integration. So let's take a look at the first graph that we already learned, which is displacement time graph. In displacement time graph, we know that to find the velocity, we use gradient. And if you have a straight line means that it has constant gradient, that means it has constant velocity. So from 2 to 4 or 5 around that, the velocity is constant. So we can just use gradient to find the velocity. But what happens if you have non-constant velocity? So if you have non-constant velocity, for example like this, as you can see, the gradient keep decreasing until it reaches 0 because the horizontal line means 0 gradient. So to find the velocity, you can apply differentiation because we know that to find the gradient at a certain point, you can use differentiation. That is called instantaneous velocity at any instant. So if you want to find velocity at this point, you can differentiate and you can find the function, and you just need to plug in the time and you can get the velocity. So we can write v equals to ds over dt. From the second graph, which is velocity time graph, we can find the gradient again, and that gives you acceleration. So using the same idea, we can write acceleration equals to gradient, which is derivative of velocity time graph function, which is a equals to dv over dt, same like before. And we can apply the opposite. If acceleration is the derivative of velocity, that means velocity is just integral of a dt. Now, from velocity time graph, we can also find the area under the curve, and that can gives you displacement. If you still remember, displacement equals to the area. Yeah, if the area is under the curve, which is above x-axis, that gives you positive displacement. If the area is under the x-axis or above the curve, that gives you negative displacement because the integral result is negative. So we can use integration instead, because integral is the area under the curve, so s equals to integral of the function v dt. Okay, by knowing all these four formula, we can summarize it into this simple diagram to help you understand easier. So we put displacement s, velocity v, and acceleration a. So to find velocity from displacement, you just need to differentiate. So v equals to ds over dt. And from velocity to acceleration, you differentiate a equals to dv over dt. But if you go up from acceleration to velocity, you integrate. So velocity equals to integral a dt. And also same for displacement equals to integral velocity function dt. Okay, some notes that you need to pay attention when you deal with the problem later. Unless stated otherwise, in work involving calculus, the displacement s will be 0 when time is 0. Sometimes the question does not tell us the initial displacement of the object, but we assume that the displacement will be 0 initially. That means it starts from the origin. Yeah. However, we cannot assume that when time is 0, velocity is necessarily 0. It's not. Yeah, it's not always starting from rest. Yeah, so it's important for you to include a constant of integration when you are using integral method. Okay, now let's prove Sufat formula using calculus, because calculus can be used to describe any kind of motion, general motion. So let's say I have an object start moving from the origin. So initially the s is 0. So s is 0 when time is 0. You also have initial velocity u, so v equals to u when time is 0, and constant acceleration a. So we can find the formula of velocity first. Okay, integral a dt, and we know that a is constant, so the integral will be at plus constant of integration. Remember, always include constant of integration. And we know that when time is 0, okay, when time is 0, the velocity is u. So that means we plug in, you get u equals to 0 plus c. That means c equals to u. So that means the first formula will be v equals to c is u plus at. This is Sufat formula that we are already familiar with, right? Now, we can also prove displacement formula. So S equals to integral v dt. Yeah. So integral v is u plus at. We use the formula before, and then u is constant, which is the initial velocity, so it becomes ut, plus a is constant, so it becomes half at squared, and then plus c. But we know that when time is 0, the displacement is 0. So when you plug in time is 0, s is 0, so that means c equals to 0. So you don't have to put c for this case. So that means you will get the displacement formula from Sufat. We already proved it. So that's how we prove Sufat using calculus. And let's start doing past paper. Let's start with the first example taken from the past paper. You have a particle move in a straight line, start from rest at time t equals to 0, and accelerates at 0.60. So the acceleration is not constant, yeah, guys. Yeah, it's in terms of t. For 4 seconds, reaching a speed of v meter per second. The particle then travels at that speed for 11 seconds and then finally slows down with constant deceleration, stopping after a further 5 seconds. The first question is, show that v equals to 4.8. Now, let's start from what we know. We know the acceleration equation, which is 0.60, and you want to find v, so v equals to integral of acceleration dt. So we integrate the a, which is 0.60. So when you integrate, you will get 0.3 t squared plus c. Now, how to find c? It starts from rest. So that means when time is 0, the velocity is 0. So when you plug into the equation, you will get 0 equals to c. So that means v is just 0.3 t squared. And then we want to find the velocity when it is v, which is when the time is 4 seconds. So you plug in 4 and you will get 4.8. So it's shown. Now, the next question is, sketch a velocity time graph for the motion. So let's sketch the graph. Velocity time graph, so y-axis is v in meter per second, and then time in second. Okay, how do we sketch the graph? First, we know that it starts from rest, so start from here. And then within 4 seconds, it accelerates at 0.60, and you already have the velocity equation from 0 to 4, which is 0.3 t squared, and we know that is quadratic, right? So the shape will be quadratic, opens up. Okay, so when the time is 4, the velocity is 4.8. And then it maintains its speed for 11 seconds. So from 4 to 11, sorry, from 4 to 15 within 11 seconds, it maintains its speed and then slows down until further 5 seconds. So until 20, it will stop. Constant deceleration means that it's a straight line going down. So that's the graph. Okay, part C. We want to find the velocity of the particle, the expression or the formula, for 15 to 20 seconds. For 15 to 20 seconds, that means you want to find the equation of this line. Yeah, in terms of time, means that the function itself. So how do we find the equation of this line? So we have two methods. I'm going to do the first one first, which is using the equation of the line itself. Yeah, to find the equation of that line, first we find the gradient, and in this case, the gradient for the velocity time graph is acceleration. So the gradient or acceleration, so just calculate the gradient. This one is 15,4.8. This is 20,0. So the gradient will be minus 4.8 divided by 5. You will get minus 0.96 meter per second square. And then use the equation of the line y minus y1 equals to mx minus x1. In this case, y is v, velocity. So let's use this. This is x1, this is y1. So v minus 0 equals to, the gradient is minus 0.96 times x, in this case is t, minus x1 is 20. So you will get v equals to minus 0.96 t plus 19.2. So this is the equation when time is 15 until 20. The second method, you can use Sufat equation, guys. Yeah, we know that using Sufat, the equation of the velocity will be v equals to u plus at. But careful with this one. For this Sufat equation, this equation assume that the time start from 0. But for this case, the time start from 15. So instead of using time itself, we use delta time or change in time. So this one, we can use delta t or change in time, which is final time minus initial time, which is 15 seconds is the initial. So we have to put t minus 15 because it starts from 15. Yeah, so we have to subtract with the initial time. So v equals to u is 4.8. Yeah, initial velocity at this point. Time acceleration is minus 0.96, t minus 15. So when you calculate, you will get the same result as before, which is plus 19.2. So that's how you use Sufat to find the equation of velocity. And the last question for this part, find the total distance traveled by the particle. So if you are given velocity time graph, the distance is just the area under the curve. This one is a curve. To find the area for this one, you use the integral and use the area of rectangle and area of triangle. So the distance equals to, okay, so integral from 0 to 4, and then the function is this one, 0.3 t square dt, plus area of rectangle is 4.8 times 11, plus area of triangle is 5, this is 5, the base, times the height, 4.8 divided by 2. So we just need to solve it. This one becomes 0.1 t cubed from 4 to 0 plus 4.8 times 11 plus this one 5 times 2.4. So we plug in 0.1 times 4 cubed minus 0 plus 4.8 times 11 plus 5 times 2.4. And then you will get 71.2 meter. So that's how you find the distance. which is the area under the curve. Move on to the next question. Here we have another acceleration equation, but now we have two different equations with different time interval. So let's see how we deal with this kind of question. So a particle P travels in a straight line starting from point O with velocity 6 meter per second. So now you have the initial velocity, which is 6 before it's 0. The acceleration of P at time t is given by this. We have two different equations. The question is find the velocity of P at time equals to 1. So how to find velocity from acceleration? We integrate. So V equals to integral A dt. But we have two different formula for A. Which one do we use? When time equals to 1, this formula apply because there is an equal sign here, right? So that means we have to integrate that, this one. So you get integral minus 1.5 t half dt. Yeah, so you integrate, you will get minus t 3 over 2 plus c. And how to find c? Once again, you plug in t equals to 0. When time is 0, velocity is 6. So you plug in 6 equals to minus 0 plus c, or c equals to 6. So that means velocity is minus t exponent 3 over 2 plus 6. And then we want to find velocity when time equals to 1. So when time equals to 1, you plug in. You will get minus 1 exponent 3 over 2 plus 6. You will get 5 meter per second. So that's how you find velocity when time is 1. The second question, given that there is no change in velocity of P when time equals to 1, find an expression for the velocity of P when time greater than 1. So let's take a look at what does it mean by no change in velocity of P when time equals to 1. So when time equals to 1 is basically the boundary between two equations, right? So when it says no change in velocity means that when you plug in T equals to 1 to both equation, you will get to the velocity equation, yeah, you will get the same value of V because no change in velocity, which is in this case is 5. Yeah, you will get same result because no change in velocity when time equals to 1. So let's see how to find the velocity. When time is greater than 1, we have when t greater than 1, the acceleration is this one, so you can integrate that. Integral 1.5 t half minus 3 minus half dt. So from here, we get t exponent 3 over 2. This one become minus 3 divided by half, or minus 6 t half plus c. Now, how do we find c? Well, we cannot plug in 0 anymore because your domain starts from 1. And we know that no change in velocity means that when time is 1, velocity is 5. So we can plug in t equals to 1, so v equals to 5. So we plug in 5 equals to 1 exponent 3 over 2 minus 6 times 1 exponent half plus c. So you will get c equals to 10. So v is just t 3 over 2 minus 6 t half plus 10. So this is the equation of the velocity when t greater than 1. Yeah, we cannot plug in t equals to 0 because the domain starts from 1. Now, how do we find the total distance traveled? Now, this is the question. Given that the velocity of p is positive for t less than equals to 4, find the total distance traveled between 0 and 4. This is very important information because when we know for sure that velocity is always positive when t less than equals to 4, means that the object always moving to the right. So there is no turning back, right? So that means the distance will be equal to the displacement. right? Because velocity is positive, that will give you positive displacement. Always, that means that will be equal to the distance. So whenever the velocity is always positive, the distance equals to displacement. This is very important because we can use integral to solve the displacement. So the distance or distance is just the integral of the velocity. But we have two velocity. Which one do we use? From 0 to 1, we use the first velocity equation, which is this one. So we integrate from 0 to 1 of the first velocity equation. Plus, we use the second equation from 1 to 4 because the equation is until 0 to 4. So from 1 to 4, t 3 over 2 minus 6 t half plus 10 dt. So from here, you just need to integrate this one. Minus 3 exponent t over 2 becomes minus 2 over 5. T exponent 5 over 2 plus 6t, plug in 1 and 0. Plus this one becomes 2 over 5, t 3 over 2. And this one becomes 6 divided by 3 over 2 becomes minus 4. T exponent 3 over 2 plus 10t, plug in 4 and 1. So we plug in 1, you will get minus 2 over 5 plus 6. We plug in 0, just 0. Plus, we plug in 4, you will get 2 over 5 x times 4 exponent 3 over 2 minus 4 times 4, 3 over 2 plus 4t. Minus, you plug in 1, you get 2 over 5 minus 4 plus 10. So when you plug into calculator, you will get exactly 20 meter. So that's how you find the distance. As long as the velocity always positive, the distance always be equals to the displacement. Now, move on to the next question. Here we have another acceleration equation. A particle moves in a straight line. At time t, the acceleration a of the particle is given by this equation. The velocity of the particle is 27 meter per second when time equals to 2. So, the first question, find the value of t when the particle is at instantaneous rest. Means that we want to find when the velocity is at an instant zero. So let's find the time. Yeah. So I want to find the velocity. We are given acceleration, so v equals to integral a dt. So we integrate that 36 minus 60 dt. So you get v equals to 36t minus 3t squared, and don't forget plus c. Now, we are given the velocity is 27 when time is 2. So we don't have the time is 0, so we can plug in 2 instead. And then velocity is 27. So 27 equals to 36 times 2 minus 3 times 2 squared plus c. So c equals to minus 33. So we have the equation of the velocity, which is 36t minus 3t squared minus 33. We want to find the time when it is 0, so 0 equals to 36t minus 3t squared minus 33. We can divide both sides by minus 3, you get t squared minus 12t plus 11 equals to 0. And then we factorize, you will get minus 1 and minus 11. So we get t equals to 1 or t equals to 11. So this is the answer. The second question, find the total distance of the particle travel during the first 12 seconds. So it's different from before. Before we know for sure that the velocity always positive, but for this case we don't know that. So how do we know when it is positive or when it is negative? If we look at the graph of the velocity graph, if you look at the velocity, it starts from minus 33 as the initial velocity. And then the function is quadratic and it's negative, so that means the shape will be quadratic facing down like this. This is 1, this is 11 as the x-intercept or the time intercept in this point. This is 12. Now, if you look at the equation here, the graph here, from 0 to 1, you will get negative integral. From 1 to 11, you will get positive integral. And from 11 to 12, you will have negative integral. So you know that from 0 to 1, the velocity is negative, and then from 1 to 11, positive, and then negative again. So to find the distance, keep in mind that the distance always positive. But sometimes, for this case and this case, the integral is negative. So you need to put negative in front to make sure that the area is always positive. So the distance will be integral from 0 to 1, but you put negative because the area is negative. So to make it positive, the function is 36t minus 3t minus, 36t, 36t minus t square minus 30t dt, and then plus from 1 to 11 is positive already, so no need to put negative sign. From 1 to 11, 36t minus 3t square minus 33 dt, and then from 11 to 12 is negative again, so negative 11 to 12, 36t minus 3t square minus 33 dt. From here, just algebra, guys. So let's briefly do it. Minus integrate becomes 18t square minus t cube minus 33t, 1 to 0, plus, and then same result but different boundary, minus this one, sorry, 12 to 11. Okay, and you plug in all of the value. So minus, plug in 1, become 18 minus 1 minus 33, minus 0, just 0. And then you plug in 11, 18 times 11 square minus 11 cube minus 33 times 11, minus plug in 1, 18 minus 1 minus 33. And then minus, big bracket, you plug in 12, 18 times 12 square minus 12 cube minus 33 times 12, and then minus, plug in 11, 18 times 11 square minus 11 cube minus 33 times 11. Now, and you plug in to calculator, you get 532 meter. That's the total distance. Move on to the last question here. Now we have the velocity equation. Before it was acceleration equation. So let's see how do we solve this. Particle P move in a straight line through origin, and the velocity formula is this one, where B and C are positive constant. At time equals to 5, the velocity of P is 0, and its acceleration is minus 13 over 12. Show that B equals to 9 and find the value of C. So let's do the first information. At time is 5, when time is 5, the velocity is 0. So you plug that in. This is part A. So 0 equals to 9 over 4 plus B over, the time is 5, so 6 square, 36, minus 25C. Yeah, you plug in 5 to the V equation, equals to 0. And the second information, the acceleration is minus 13 over 12, but we know the acceleration equation, so we can differentiate the V. So differentiate this, yeah. So you will get minus 2b over t plus 1 cube minus 2ct. And then the acceleration is minus 13 over 12. The time is 5, so minus 2b over 36 minus 10c. Now, we have two equations. What we can do is we can simultaneously solve it. So from here, we can have 25c equals to 9 over 4 plus b over 36. So c is just 1 over 25 times 9 over 4 plus b over 36. So we plug that into here. You get minus 10 times 1 over 25 times 9 over 4 plus b over 36. Okay, we just need to solve it. Minus 10 and 25. 10 and 25 becomes 2 and 5. Yeah. And then minus 2 over 5 times 9 over 4. You will get minus 9 over 10. And then we also have minus 2b over 180. Okay, we solve this using calculator. This plus this, you will get minus 11 over 60. And we can simplify this with this because both has b. You will get minus 11 over 540p. Minus 11 cross out, so b is just 540 divided by 60, which is equals to 9. So it's shown. And to find c, you already have b. To find c, just plug in. C equals to 1 over 25 times 9 over 4 plus 9 over 36. You will get 1 over 10 from it. So this is B and C. Okay, move on to the last question. It's about, given that the velocity is 0 only at time equals to 5, find the distance traveled in the first 10 seconds of the motion. Like the previous question, we have to know when the object is instantaneously at rest. Because when it is at rest, there is a change in velocity from negative to positive or from positive to negative or vice versa. So we need to know when it is positive and when it is negative. But we are given information that velocity is 0 only at time equals to 5. So you want to find from 0 to 10 within 10 seconds. It's at rest at 5. So we have to know whether the velocity change from positive to negative or from negative to positive. So how do we know that? Let's plug in when time is 0. So when time is 0, you want to find the velocity. 9 over 4 plus b is 9, so 9 over 1 square minus c is 1 over 10, 1 square. So when you calculate this, you will get 11.15, which is positive. So that means the velocity from 0 to 5 will be positive, and then 0 here, exactly 0, and there's a change in velocity graph, becomes negative from 5 to 10. This is very crucial information because from here we can find the distance. The distance, velocity is positive. When you integrate that, you will get positive integral result. So integral from 0 to 5, the velocity equation is 9 over 4 plus 9 over t plus 1 square minus t square over 10. You plug in ct square to the equation. But from 5 to 10, you will get negative integral. So you have to put negative integral from 6 to 10, sorry, 5 to 10 of the same function. Okay, so we integrate. You will get 9 over 4 t, and then this one you integrate, you will get minus 1 plus 1, so you will get minus 9 over t plus 1, and then this one you will get t cubed over 30 integrated from 0 to 5 minus same integral result but the boundary is from 5 to 10. Okay, so we plug in 5 and 0. You plug in 5, you get 45 over 4 minus 9 over 6 minus 1 to 5 over 30. And you plug in 0. But if you plug in 0, be careful because it's not always 0. This is 0, 0, but this one 0 plus 1. So that will give you minus 9 when you plug in 0. Minus, you plug in 10, you will get 90 over 4 minus 9 over 11 minus 1000 over 30, and this big bracket, minus, you plug in 5, you will get this result. Same thing. Then close bracket. Nah, just solve it using calculator. The first one, you will get 175 over 12 minus the second integral. You will get minus 2275 over 132. And then when you add them, you will get 31.8 meter. So that's how you find the distance. You have to know when the velocity is positive and when velocity is negative. Whenever the velocity is negative, the integral is negative, so you put negative before integral to make it positive.